Alright, this is part 2 of our base plate. So what we're going to finish up doing now is creating the bolt, the nut, and we're going to create the assembly. We'll start with the nut since it's the most simple part, and we're going to use it over for the bolt because they have the same top. So we start with the understanding if it's a 1/2 inch by 13, so it's 13 threads per inch. So we'll create that hexagon, which is 0.75, and its depth is 0.32. This is the side view of it. So let's go ahead and do that. Back to our drawing. We start with a hexagon. So under rectangle, there is a polygon command. So this is your home tab, draw, under rectangle, the arrow next to it. Go to polygon, and we're going to type in how many sides it has. So this one has 6 sides. So we type in 6. It's asking us to specify the center of the polygon, so we're going to specify it somewhere around here. And it's going to ask us inscribed and circumscribed. That pretty much means which way are we dimensioning it, so that when you can either dimension it from here to here or from that point to that point. Always get this confused, so let's try to inscribe and you see the difference. So do it inscribed, and we're going to type in the overall is 0.75, so we got to type in the radius, specifying the radius. So it's going to be half of that, which is 0.375. So that's inscribed. Now if we go back to that polygon, we type in 6 again, select the place. This time we're going to do a circumscribe, and I'm going to type in 0.375 for the radius. So now if we dimension these out, you may see the difference. See, one is 0.65 and one is 0.75. Well, we did the exact same steps, except instead of inscribe, we did circumscribe. So, circumscribed selects the edges. Inscribed goes from the corner to corner. So if I dimension it from here corner to corner, it should be 0.75. So I'm going to type that in for you guys. This one is inscribed. I think I spelled that wrong. Inscribed, yeah, and this is circumscribed. So it's a good reference. I spelled. Whoa, that's. Ah, is it? I don't think it is. There it is. My bad. Good thing the newer version, 2010 and up, there is spell check. That's a cool thing to do. If you guys have a lot of text in your project and you're not good at spelling for some reason, like me, you can type in the word spell. It's the easiest way to do this. You type in spell and click enter, and that's going to give you some of these options. Yes, we're using American English, so we're going to use that, and it's going to check the entire drawing. So you just click start, and it's going to check out everything. So stuff that, has easy, different meaning, but you know what it is, and you're supposed to leave it, you just do ignore all, or ignore. DWG, ignore all, because we want that Oakton as actually a word, and it checks everything, even in your paper space. So it's really nice. Sometimes you won't realize you misspelled something until it's too late. I had a project I sent out, instead of writing piping, I wrote pimping. The client was very, very nice and pointed out to me with a good laugh. So keep that in mind. Spell check, even though it checks it, you still gotta keep an eye, because pimping is a word. Anyways, so we are gonna be using the circumscribed to get our polygon. Actually, this is the one we want, so I'm just gonna make a copy of this. I'm going to use this as a reference. This is for you guys to see. And I need to rotate so the pointing part is upwards. It doesn't really have to be, but the way the drawing shows it, that's how I'm going to create it. Use the rotate command, select that object, select like somewhere in the center, doesn't matter where, and we're just going to rotate 90 degrees. If you have ortho, you just move your mouse down and it rotates that 90 degrees. We need a circle inside, which is going to be a little tricky, so we have to draw a line from corner to corner or from midpoint to midpoint, and we're going to create a circle at the midpoint, making sure our midpoint OSNAP command is activated. Select there, and we type in D for diameter. It's going to be 0.5. And we can finally delete that reference line. So we have our hexagon. If you see the PDF, there is actually additional, like a weird dashed line sort of thing. We're not going to go over that. That's a little more advanced, but we can draw a dashed line for showing of its thread. It's up to you if you really want to do this, or you could just leave it as is. That's be fine because we're specifying what it is here. So you can assume whatever is being specified is more important than what is drawn. So don't worry about that for now. We're going to use this object as a reference to create a side view of it. We're going to use the line command. We're going to move our mouse over the endpoints. Just going to move over about some distance so we can actually draw the actual part. I'm going to draw a line, vertical line that is a lot longer than the object because I can't decide. Actually, I can show you guys a trick. Line command, I'm going to go to the endpoint, scroll over, making sure my O track is on. Right here, it's activated. That way it gives me that green line. I'm going to click a point here, and I'm going to move over to the other endpoint. And then move over back to my drawing, where I'm drawing my line. And you can see that it creates its own like snap. So then when we have that snap, that's all we need. So I'll show that one more time. You go to line command to the endpoint, you move over, click, then you move over down, get to the endpoint that you want the same distance, and you scroll over back to your drawing, and it will just snap to it. Just like that. And you just click. The thickness is 0.32, so I can do that. 0.32 from both sides. 0.32. I'm going to close that up. And again, I'm going to use the reference line here, these endpoints. Just move them over and create those lines. Okay, so we have that, which is great. So I'm going to move over. You can move the stuff into a better location if you like. Minimizing your drawing size if you keep everything closer, but not too close. That way when you do print out an object in your paper space, everything gets bigger, it's easier to see. Right now you can't even see the hatching. Okay, so we have that part. The good part is this is the same size as our bolt. So we're just going to copy this one for the side view of our bolt. You can see on the PDF. We'll zoom this out a little. It is the same size. And it's also the same side view. So we're going to create that side view here. So we're going to take that side view, copy it over, making sure you have ortho, that way everything is aligned. And now we got to create the actual bolt. Tricky part is here, it doesn't specify how long this threaded area is. There's specifications that you can go online and find out what the regular standard bolt is, but we'll make it easy. We'll just say this is 2 inches. So do a 2-inch by 1/2 inch normal, a 2-inch by 1/2 inch with chamfers, and we'll do a dash line that is maybe 1/16 in. So I'll show you how to do that now. From polygon, we go back to a rectangle. We draw a rectangle by clicking a point on the screen. Type in D for dimension. We do 2-inch by 0.5. And we select it on the screen. We place it on the screen. We use the move command. We select the rectangle that we created. Click space or enter. We select the midpoint. and we move it to the midpoint of our side view of the hex. Again, we copy this rectangle over one time since our overall is 4 inches and we did 2 inch and 2 inch. Makes it a lot easier. We go to our chamfer command. We type in D for distance. The chamfer distance is 0.06 both ways, so 0.06 once and 0.06 again. And then you can chamfer the edge. In addition to that, we're going to use that same chamfer to create a dashed line that creates like a threading. So we create the line command. From that end chamfer, we can just create these two lines here, and we change the layer into a hidden. So that shows the threading. And actually, in addition to that, you have to add those dimensions, so forth. Even the dimension here. And of course the ones with the text also in here. But I'm not going to go through that since you guys got a good handle on the dimensioning. Once we have all this completed, what we want to do is start putting it all together. Our first step would be to create the top view. So let me zoom out the PDF. This is the top view of the assembly. So we're going to take a copy of this object here without the dimension, because it's not going to help us. We can delete this dashed line. It's no longer needed. And we're going to start placing things on the top view. So the first one will be the top view of this part here without the dashed lines, except the problem is we did the bottom view, so this wouldn't work that well. We'll actually have to take the top two circles, which is the top two biggest circles from here. We're going to copy it over into the location here. So that was these two top circles. These two smaller circles we just removed. We exchange this line into a object line. Since it's a top view now, it's no longer hidden. Now we have these four circles here that we need to put our bolts into. Here's our bolt view. We take that bolt, we copy it based on the center of the circle. If you cannot select the center of the circle, hover over the actual circle and then a center mark should appear. That's where you can snap it on and place it into each of these circles. The circle is actually size is the same, so you don't have to worry about deleting anything unless you like to. In addition to that, we also need to use this circle here, which is the washer, the big one, and copy it over like so. What else are we missing? We're missing the washers for the hexes. Our washers are actually right here. So we're just going to use the exterior circle of this washer, and we're going to copy it over from the center mark or center to all of these hexagons. Just like the drawing, you see it's overlapping, and that's okay. That concludes our top view of our assembly. Now we have to do the front view. Before we start doing the front view, draw a reference line from the midpoint. That way it's all nicely aligned. Something like that distance. And that way we can take this whole assembly here, copy it over from the midpoint, the bottom midpoint, to the bottom midpoint here. That reference line can be now removed, and we can add in the additional parts, like this one, which will actually snap it from the midpoint here into the endpoint. And of course those dimensions are not needed. We have that. It looks perfect. We go with the next part, which will be this here. We may have to remove these lines up here because that will interfere with our drawing. So we copy it, endpoint here, Oops, I don't have the endpoint here, so that's going to be a tricky thing to do. So I have to draw a reference line, which later on I'll remove. So I copy this part here from the bottom midpoint to the bottom midpoint here. Again, these lines are not needed, so we remove these top and bottom lines. Or actually, it might have been easier to trim it. So we can undo, trim, center, and then you'll see that there's still too many lines. So we clean this up. This should be shorter. Well, actually, no, that should stay. No, that should be shorter. That should be shorter. So all I'm doing is clicking the endpoint, and just dragging and snapping it on to its exact specifications. Like so. Now that looks correct, except for I should have an opening here and here. So I'm going to use the trim command, trim those insides out. Next, we place our bolts. We take a copy of our bolts, like so. And what we need to do next, once we copy it, is rotate it. So we select it again, use the rotate command, select anywhere by the object, and just move your mouse till you see the right rotation, making sure your ortho is on, otherwise it won't work. So we have that, and we start moving it in based on the center point of this, which we don't have. So we have to figure out how to create that center point. Or we can just click an endpoint here, the corner, and the endpoint here, the corner. And that would work too. So we use the copy command, select the entire object, get that corner here, select it here, and oops, I just realized we missed the washers. So I'm going to undo. We got to put the washers in first, and then we can put in this bolt. Here's our washer. Take it, make a copy of it. Again, we have to rotate, so we select it, rotate command, rotate around, move command, or copy command, since we have a lot of these. I'm going to copy it based on this dashed line I have here that we created before, and move it, copy it here and here. I'm going to do it once more. Use the copy command, select the object. This I'm going to select the top portion of the washer, this edge, and copy it over from this point to this point. Actually, this does not look correct. The actual dimension inside here is a bit bigger, and it should be centered. So I'm going to actually delete these, or you can undo. Most of the time, washers are bigger than the bolts. That's, gives a little free play. So we will actually have to create these center lines for these here. The easiest way to do that, I'm just going to create two reference lines from our top view that just go way across our front view. And that's where I can start copying it based on the midpoint and placing it at that intersection point. Do the same with the bottom, copy it over, but use the top line as our midpoint, copy it over. Once you have that, then we use the bolt, copy that over, midpoint again, like so. And then we also need the bolts, so we take a copy of the nut, so we get a copy of the nut. We rotate it like we did before, and we copy it to screw on to our bolt. Our reference lines are no longer needed, and these copies are not needed, so I remove those. And technically I can delete these hidden lines, or I can just turn off that layer. And so I becomes very nice and clean. And that concludes the front view full assembly. That's how you basically do the drawing. We go to our title block, double click on our viewport, zoom out to try to fit the whole assembly into our drawing as efficiently as possible, as big as possible. That way it's a lot easier to view, and make sure it's in scale, otherwise people won't be able to measure it out if there's missing dimensions. So make sure your objects are away from the center of the drawing. Just move them over, or even rotate and place them in a different location if you like, as long as all the data fits and it looks nice. So you can see I'm putting them closer together, but not going too close. Otherwise, the text and dimensions will get a little crazy. I'm also going to move this here. And finally, there we go. So now if I go into block space, you can see it becomes very nice and clean. Pick a scale, use the decimal set, not the fractions, because we are in mechanical. I wish I could fit 1.5. If I can't fit it to the scale I'm looking for, I can go in between. I guess 1.5, 1 to 2.5. So if you do want to do a custom size, because you think 1/4 is too small, you can go to custom, and you can add one. So you add 1 to 2.5, 2.5. Okay. Again, you have to go back here and make sure you set it up for that. And that looks just about right. Again, name, date, and everything, and you're done. Don't forget to save your work when you're complete.